March 1968. Route 9, Khe Sanh, Republic of Vietnam. Inside the M48A3 Patton, 4 crew members were running standard convoy operations, buttoned up, visibility limited to periscopes, engine noise drowning out external sounds. 1 second, routine. The next second, a 2.25 kilogram shaped charge warhead traveling at 300 meters per second struck the rear hull. The copper jet punched through 38 millimeters of armor, ignited hydraulic fluid, and turned the crew compartment into an oven. Total cost of the weapon system that killed 52 tons of American armor, less than the tank commander's monthly salary. This is the operational reality of the RPG-7. Not a game changer because it was sophisticated. A game changer because it was sufficient and sufficiently ubiquitous. By conservative estimates, 9 million RPG-7 launchers have been manufactured since 1961. They've destroyed thousands of armored vehicles across every major conflict of the past 60 years. And they're still in frontline service today, from Ukraine to Yemen to the Sahel. The Soviet experience in the Great Patriotic War established one doctrinal absolute. Infantry must possess organic, man-portable anti-armor capability. The RPG-43 and RPG-6 stick grenades provided close-range solutions, but they required suicidal proximity. The 14.5 mm PTRD anti-tank rifle became obsolete by 1943 as German armor evolved. What infantry needed was standoff capability, something that could engage armor at 100 to 300 meters without requiring the operator to die in the attempt. The RPG-2, introduced in 1949, was the Soviet Union's first rocket-propelled grenade launcher. It worked. 80 mm warhead, shaped charge principle, effective range of 150 meters. It could penetrate 180 millimeters of rolled homogeneous armor, enough to defeat the frontal armor of most Western tanks of the early 1950s. But by 1960, armor had evolved. The M60 Patton boasted 200+ millimeters effective frontal protection. Chieftain was in development with composite schemes. The RPG-2 was already marginal. In 1961, Soviet designers at the Basalt State Research and Production Enterprise finalized specifications for a successor system. Requirements were explicit. Penetration of 260 millimeters plus RHA, effective range of 300 meters minimum, weight under 7 kilograms loaded, maximum cost per unit of 100 rubles, roughly 1/10 the cost of a PKM machine gun. The weapon had to be simple enough for conscripts with minimal training to operate under combat stress. It had to function in temperatures from -40 degrees Celsius to +50 degrees Celsius, and it had to be manufacturable by the tens of thousands. The development order came in 1958, but the conceptual work had begun earlier. Basalt's engineers weren't starting from theory. They were starting from failure analysis. Combat reports from proxy conflicts showed RPG-2 crews attempting frontal engagements against M48 Pattons and achieving nothing but their own casualties. British Centurions with sloped glacis plates were deflecting strikes that should have penetrated. NATO metallurgy was advancing faster than Soviet warhead technology. The core insight: don't just increase penetration, change the entire system architecture. The RPG-2's integrated warhead meant that improving lethality required replacing the entire weapon. Expensive, logistically impossible at scale. Basalt's solution was modular separation, a reusable launcher tube paired with interchangeable rocket-propelled grenades. This single design decision transformed the weapon from a disposable tool into a platform that could evolve across decades. The engineering challenge was stability. Previous rocket-propelled systems, American Bazooka, German Panzerschreck, suffered from accuracy degradation beyond 100 meters. Basalt solved this through two-stage propulsion and pop-out fin stabilization. The initial expulsion charge cleared the operator's position without revealing launch signature through sustained rocket flame. Mid-flight motor ignition provided acceleration without compromising concealment. Fins deployed automatically, stabilizing trajectory without adding weight to the stored configuration. When the RPG-7 entered service in 1961, Soviet planners weren't thinking in terms of individual weapon performance. They were thinking in terms of systemic proliferation. Every motorized rifle squad across the Warsaw Pact would carry one. Production licenses were negotiated with Allied states before the weapon even completed field trials. Within 4 years, factories in Poland, East Germany, Bulgaria, and Romania were producing domestic variants. By 1970, Egypt and China had begun licensed production. The weapon's simplicity, no electronics, no complex machining, no proprietary components, made this proliferation economically feasible. Vietnam provided the operational proving ground. Between 1965 and 1973, North Vietnamese Army and Viet Cong forces employed RPG-7s extensively against American and ARVN armored units. U.S. casualty reports logged RPG strikes as the leading cause of M113 APC losses, accounting for approximately 25% of total armored vehicle casualties. The M113's aluminum hull, 38 mm maximum thickness, provided zero protection against PG-7V penetration. Marine Corps after-action reports from the Northern Thai Corps area recorded 73 M48 Patton tank losses between 1968 and 1971. Of these, 34 were attributed to RPG fire, 46.5%. Frontal turret hits were rare but catastrophic. Side and rear hull strikes frequently ignited ammunition or fuel. Crew survival rates for penetrating hits averaged 40%. Lower than mine strikes, higher than direct artillery impacts. The lethality wasn't just mechanical, it was psychological. Tank crews knew that any vegetation line, any rubble pile, any urban alleyway could conceal an RPG team. Afghanistan, 1980 to 1989. Soviet mechanized forces faced the same weapon system they'd created, now supplied to Mujahideen fighters by Pakistani intelligence and CIA channels. Over 1,100 Soviet armored vehicles were destroyed or damaged by RPG fire during the conflict. The BMP-1 infantry fighting vehicle, aluminum hull, 33 mm maximum frontal armor, proved catastrophically vulnerable. PG-7V warheads penetrated frontally at ranges exceeding 250 meters. Operational doctrine shifted. Convoys adopted wider vehicle spacing, infantry screening increased, and reactive armor packages entered emergency development programs. Chechnya, 1994 to 1996. Despite ERA upgrades, Russian armored units suffered devastating losses in urban terrain. During the initial assault on Grozny, the 131st Motor Rifle Brigade lost 102 of 120 armored vehicles in 48 hours, primarily to RPG ambushes from elevated positions. Vertical strikes onto thin roof armor bypassed frontal ERA entirely. The lesson was doctrinal. Armor without infantry support in restricted terrain equals death. Iraq, 2003 to 2011. Updated warheads changed the equation. The PG-7VR tandem charge grenade, introduced in 1988, featured a precursor charge to defeat ERA, followed by a main penetrator capable of breaching 600 mm plus RHA equivalent. U.S. forces documented multiple M1 Abrams mobility kills from PG-7VR strikes to track assemblies, engine compartments, and side skirts. Crew fatalities were rare. American armor doctrine emphasized survivability, but mission kills were operationally significant. The RPG-7 is mechanically simple. A reusable launcher tube, a detachable optical sight, a percussion firing mechanism, and the warhead, the actual projectile, which does all the work. Standard launcher specifications: 950 mm length unloaded, weight 6.3 kilograms, recoilless design using a venturi system to vent propellant gases rearward. This eliminates the Newton's third law problem. No recoil, meaning no heavy breach mechanism, no complex hydraulic buffers, No requirement for a prone firing position. An operator can fire standing, kneeling, from inside a building, from a rooftop. The backblast is dangerous. 15 meters of clear space required behind the weapon, but manageable with training. The warhead, typically the PG-7V or PG-7VL variant, is where physics becomes violent. 85 millimeters diameter, 2.25 kilograms of explosive shaped into a conical copper liner. On impact, the explosive detonates from the rear forward, collapsing the copper cone into a superplastic jet traveling at approximately 8,000 meters per second. This isn't an explosion punching through armor. This is hydrodynamic penetration, the copper jet behaving like a fluid, flowing through steel the way water flows through tissue paper. Penetration capability: 260 millimeters of rolled homogeneous armor at 0 degrees obliquity. Against sloped armor, effectiveness degrades based on angle. Against composite armor schemes incorporating ceramics or depleted uranium, like the M1 Abrams frontal array, penetration drops significantly. But side armor? Rear armor? Engine decks? The PG-7V will penetrate T-72 side armor at any practical engagement range. It will penetrate M2 Bradley fighting vehicles from any angle. It will kill BTR-80 armored personnel carriers through the front glacis. The optical sight, PG-07 or variance, provides range estimation via a stadiometric rangefinder. The operator measures the apparent height of the target against reticle markings, consults a mental table correlating target size to range, and adjusts the sight's elevation. This works, not with the precision of a laser rangefinder or ballistic computer, but well enough that trained operators consistently achieve first-round hits within effective range. Later warhead variants increased lethality. The PG-7VL added a precursor charge, a small shaped charge that detonates reactive armor blocks before the main charge arrives. The ERA block detonates against the precursor, disrupting nothing. The main charge arrives milliseconds later, penetrating the now exposed base armor. The thermobaric variant, TBG-7V, dispenses with shaped charges entirely. On impact, it disperses a fuel-air mixture that then detonates, creating overpressure that collapses structures and incinerates anything in the immediate blast radius. Designed for bunker busting and urban combat, it proved effective against fortified positions and unarmored vehicles. But the core principle remained unchanged: simple physics, applied violently. The RPG-7 succeeded because it solved a tactical problem that transcends technological eras: how to give infantry credible anti-armor capability without requiring combined arms support. Soviet doctrine emphasized mass mobilization, rapid mechanized offensives, and distributed anti-tank defenses. The RPG-7 fulfilled the third requirement at scale. Every motor rifle squad carried 1. Every airborne platoon carried 3. The weapon was ubiquitous because it was affordable, reliable, and required minimal logistics. Proliferation extended its relevance beyond Soviet planning. By 1975, production licenses existed in Egypt, China, Romania, and Iraq. Chinese Type 69 copies flooded Third World markets. Egyptian variants armed Palestinian groups. Romanian models equipped Warsaw Pact allies. The weapon's modular design allowed continuous warhead upgrades: PG-7VL, PG-7VR, PG-7VM, without replacing launcher infrastructure. A weapon fielded in 1962 could fire munitions developed in 2005. The RPG-7 exploited a doctrinal gap in Western armor employment: the assumption of open-terrain dominance. NATO tank design prioritized frontal armor and long-range gunnery. Urban warfare, asymmetric conflicts, and close-terrain fighting negated these advantages. RPG teams operating from buildings, sewers, or prepared positions could engage side and rear aspects at under 100 meters, ranges where even modern tanks are vulnerable. Popular perception portrays the RPG-7 as an inaccurate, short-range desperation weapon. Reality is more nuanced. Effective range against stationary armored targets is 200 to 300 meters, limited by projectile velocity and sight magnification, not inherent in accuracy. Trained operators achieve hit probabilities exceeding 50% at 200 meters. The weapon's reputation for poor accuracy stems from untrained irregular forces firing at extreme ranges or moving targets. Another myth: the RPG-7 can destroy any tank. False. Frontal strikes against modern main battle tanks, Leopard 2 A7, M1A2 SEPV3, T90M with advanced ERA, rarely achieve catastrophic kills. Penetration occurs, but crew survivability systems, spall liners, and blowout panels mitigate lethality. However, mobility kills, sensor damage, and side/rear penetrations remain viable. The RPG-7 doesn't kill every tank. It kills enough tanks to matter. 63 years after introduction, the RPG-7 remains in frontline service across 120-plus nations. It has destroyed more armored vehicles than any other man-portable weapon system in history. It has reshaped armor doctrine, driven the development of reactive armor, APS systems, and urban warfare tactics. It achieved this not through technological superiority, but through sufficient capability at unsustainable cost disparity. The RPG-7 is not invincible. It is not unstoppable. But it is ubiquitous, adaptable, and economically rational. For insurgent forces, mechanized infantry, and state militaries alike, it remains the baseline answer to the question: how do we kill armor? Until something cheaper, simpler, or more effective emerges, and nothing has, the RPG-7 will continue to define the nightmare that keeps tankers awake.